Alright, here we're going to talk about circles. Again, circles are a conic section that you have seen a lot or dealt with a lot before. It's something that comes up on an ACT usually. So it's very important that we know the standard form of the equation of a circle and how to apply it depending on your given information. So our standard equation of a circle is the quantity x minus h squared plus y minus k squared equals r squared, where the center of the circle is the point hk and the radius of the circle is r. Notice that it's x minus h and y minus k, so if h is a positive number, this is subtraction. If h is a negative number, this would then become addition because we would have minus a negative, and the same is true for the k. Also, notice on your packet that you were given the Pythagorean Theorem and the distance formula in this circle unit. And that's because the Pythagorean Theorem, the distance formula, and the equation of a circle in standard form are all the exact same thing. Well, why is that? So, how is the equation of a circle related to the distance formula in the Pythagorean Theorem? Great question. I kind of already answered it, but we're going to show or prove how they're related. So if I have the center of a circle is at the point 1, 3, and I have a point on the circle is 5, negative 2. So let's go ahead and plot these points. So the center is at 1, 3, and I have a point on the circle that is at 5, negative 2. So my circle looks something like that. That's not perfect, so I'm going to delete it, but that's what it would look something like. Alright, so now if we wanted to write the standard form of this circle, well, we have the center. So I know that this is my h, and this is my k. Okay, I need to find the radius. How do I find the radius? Well, I know that the radius is the distance from the center to any point on the circle, and since I know this point, I could use the distance formula. Well, where does the distance formula come from if we're on our coordinate plane? Well, if I draw this triangle in, this is the radius. Well, how do I find the length of each side of the triangle? I know that this point here is the point 1, negative 2. So therefore the distance from this point, which is 5, negative 2, to this point, which is 1, negative 2, is going to be 5 minus 1, which is 4. The distance from the center, which is 1, 3, to the point 1, negative 2, is going to be negative 2 minus 3, which is negative 5. However, we're talking about a distance, so we're going to write in positive 5. So now, how do we find the r? Well, we can use Pythagorean Theorem, and we know that 4 squared plus 5 squared equals r squared. So we get 41 equals r squared. We know r then is the square root of 41, but if all we're trying to do is write the equation of the circle, we can write our equation as x minus 1 squared plus y minus 3 squared equals 41. And now that is our equation of the circle. And just to emphasize, well, we did this by thinking about the Pythagorean Theorem, which also happens to be, hopefully we recognize that is the distance formula. And this step here, 5 minus 1, and negative 2 minus 3, that's your x minus h squared and y minus k squared equals r squared. What do I mean by that if you're a little bit confused? Well, if I plug in, this is 5 minus 1 squared, which was my 4 squared. This is the negative 2 minus 3 squared, which was my 5 squared. And then that equaled r squared, or 41. And so that hopefully shows you how the Pythagorean theorem, the distance formula, and the equation of a circle in standard form are all the exact same thing. The reason why I'm emphasizing this is because I believe that most of you have the Pythagorean theorem pretty well memorized. A lot of you might forget the standard form of a circle sometimes, but if you remember that it is the same thing as the Pythagorean theorem or the distance formula, then it's a lot easier to remember the equation. Okay, so now that we've seen that, I want you to try a problem on your own. I want you to find and graph the equation of a circle that has endpoints of a diameter at 10, -10, and 0, 14. So these are 2 points that are on the circle. They are endpoints of a diameter. So you are trying to find and graph the equation of that circle. So pause the video, do that, unpause when you're ready to check your work or when you get confused. Alright, so you should end up with the standard form of the circle is x minus 5 quantity squared plus y minus 2 quantity squared equals 169. So we know that the radius is 13, the center is the 0.52, and so if we were to graph this, again, this is definitely not going to be perfect. I would have a circle like that. That's a beautiful circle, almost a perfect circle. So if you're confused on how we got that, well, first I used the midpoint formula. I use the midpoint formula to find a center. So if I know the endpoints of the diameter, I know that the center is halfway in between. So now, the midpoint formula, average the x values, so x1 plus x2 divided by 2, and average the y values, y1 plus y2 divided by 2, plug in those values, and I end up with the 0.52. That's my center. Then I used the equation of the circle, and one of the points, because this is the same thing as the distance formula or the Pythagorean theorem, to find r squared. So that's how I got r squared was 169. So I plugged in 0 for x and 14 for y when h is 5 and k is 2. That's how I get my equation of the circle. Now another thing to point out, well, what if you had forgotten the midpoint formula? Well, you could have done something similar to what we did on the last problem and draw a giant right triangle, used the Pythagorean theorem to find the diameter, divide that in half to find the radius. Now from there you still would have to figure out well, where exactly is that center point going to be, so it would have been a little bit more work, but it's just a different approach to the problem. The easier way is to just remember how to find the midpoint. If you don't remember how to find the midpoint, do you remember how to find an average? Because that's all you're doing when you're finding a midpoint is averaging an x value, averaging x values, and averaging y values. Okay, last example. I want you to find the equation of a circle with the center at 1, -3 that contains the point -2, 5. Contains the point means that that point is on the circle. Pause the video, find the equation of the circle, unpause when you're ready to check your work. Okay, so our equation in standard form should be x minus 1 quantity squared plus y plus 3 quantity squared equals 73. How do we come up with that if you are confused? Well, I plugged this center in for h and k, so I did x minus 1 quantity squared plus y plus 3 quantity squared equals r squared. And then I plugged in -2 for x and 5 for y to solve for r squared. Again, this is the exact same thing as using the distance formula slash the Pythagorean theorem to find r squared. We do not need to actually find r. R would be the square root of 73, but since all we were asked to do is write the equation in standard form, we are now done. So again, memorizing and understanding the equation and how to use the equation of a circle in standard form is very important. However, if you forget it, try to remember that it is the same thing as the Pythagorean theorem, which is also the same thing as the distance formula.